So first question that we got is the binary search algorithm itself. Now how does it work? Just for an example, we are given an first of all we should have a array in ascending or descending order. It should be sorted. Okay, so we have suppose the same example we'll take -1 0 2 4 6 8. So -1 0 2 4 6 8. Okay, so if we search it like one by one, that uh, will get us complexity of n. Okay, n square. So what we will do here is in binary search we'll try to figure out the mid element. So we'll put the left here, we'll put the right here, and we will always check the mid element. So what we will get here, so let's put indexes also 0 1 2 3 4 5. So the mid element is it will be at right plus left by 2, right plus left by 2, but don't do it. Okay, the reason being when we add it, it can get a bigger number, right? So that is not the right approach. The right approach will be right minus left by 2 plus left. If we do this, this will also get the mid element. Okay, because suppose our right is here and left is here, we will know where is the mid from this guy, and then we know the left, so we add it. So next what we will do here is, let me erase it. Okay, so we figure out the mid here. The mid here will be 5 2. Okay, suppose we got the mid here first, then we will check and we have to figure out where is suppose 6. We have to get 6. Okay, so now we will check whether 6 is greater than or less than or equal to mid. If 6 is equal to mid, return the answer, but here it's not. 6 is greater than mid, right? So it cannot lie in this portion, because in this portion every number is below 2, so update. Okay, similarly now again we have to figure out next time. So this time the mid element suppose is this. Okay, so again if we see the mid is lower, so we move the lower bound here because it cannot lie here. It should be somewhere in this guy. Now we figure out the mid. This will be the mid, and now mid is equal to target, so return the mid. So return mid. So in this way we keep cutting the search space in half. Okay, so the complexity becomes log n. Now let's try to solve the question. So this is the question. We'll say okay, let left equal to 0 and let right equal to nums dot length -1. Okay, and we have to do it till left is less than equal to right. Okay, because once left crosses right, that is not possible, right? Once, so the best we can get is when left and right will both lie at the same position. So while left is less than right, what we'll do is we'll figure out the mid. So const mid equal to, same logic, we have to do math dot flow because indexes cannot be in decimal, and then right minus left. Okay, this is again in a bracket by 2 plus left. So we got the mid element, and then we'll check. Okay, if nums of mid is equal to target, then return mid. Okay, else if there can be two scenarios. First scenario is if target is greater than nums of mid, or the last guy where target is less than mid. If target is greater than mid, then we know it happens on the right side, so right side of the search space. So let's move the left to mid. If not, let's move the right to mid. Okay, and anyways we have already checked mid, so we know it cannot lie on this. So when we move the left, move it to the next guy and move it to the next guy. Okay, and once this loop is done and we have never encountered mid, then this means we have not find our answer, so return -1. Let's run, submit.